ArcelorMittal is the world's leading steel and mining company. Our steel is at the heart of the modern world, forming the fabric of life from railways to cars to washing machines to iconic towers and sculptures. While the history of steelmaking dates back 2 centuries, the methods used to manufacture steel continue to evolve in order to meet customer requirements. Our steel is used in some of the most advanced applications in the world. 2 elements are critical in the economics of steelmaking and the quality of our products: the quality of raw materials and being as self-sufficient in iron ore and coal as possible. The integrated route is used where high volumes of steel are being produced, or for the production of high purity steel grades. The first stage is the iron making. This starts with the processing of iron ore, the main raw material used in primary steel production. Fine-grained iron ore is processed in the sinter plants into coarse-grained lumps for use in the blast furnace. Coal, another important raw material in iron making, is cleaned of impurities in a coke furnace to make an almost pure form of carbon called metallurgical coke. A mixture of iron ore, coke, and fluxes, purifying agents, such as lime, are then heated in a blast furnace, reaching temperatures of up to 1550 degrees Celsius. As the coke combusts in the furnace, it reduces and melts the iron ore to produce hot metal. The hot metal is then transported in torpedoes to the steel plant, where it is loaded into basic oxygen furnaces together with scrap and fluxes. Pure oxygen is blown onto the metal bath to burn the excess carbon and impurities. The finished product is liquid steel. The electric arc furnace route is suited to produce low volumes or alloyed steel grades. The process involves using recycled steel scrap and pig iron, which is melted at more than 1600 degrees Celsius in an electric arc furnace. Steel is the most recyclable material in the world. Thanks to the use of scrap to produce new steel, we are today recycling steel produced over 150 years ago. Secondary steelmaking is a critical step in the steel production process, acting as a final steel refining stage before casting. The liquid steel and ferroalloys are poured or tapped into a ladle. Other alloying elements are added to deoxidize the steel and achieve the required chemical composition. The continuous caster is the final stage of the steelmaking process. Molten steel passes through continuous molds where it is solidified and formed into semi-finished products such as slabs, blooms, and billets. Semi-finished products are rolled at a hot rolling mill to change its dimensions and give the mechanical properties of the steel. Blooms, billets and beam blanks are rolled to produce long products such as rebar, wire rod, sections and rails. Slabs are rolled to produce hot rolled coils or plates. The blanks used for rolling long products are loaded into a reheating furnace and heated up to 1300 degrees Celsius. When rolling beams or special sections such as rails and sheet piles, the blank is reduced in several steps in order to achieve the required size and shape for the finished product. Merchant bars and rebars are usually rolled in continuous mills. In all rolling operations, the temperature of the stock is crucial. If the temperature is too low, surface defects can form on the steel. If the temperature is too high, energy is wasted. Therefore, many rolling mills producing high-quality grades are equipped with devices to control the temperature during the rolling process. At the end of the process, the bars cool down to ambient temperature and can be cut to size. Prior to further reducing the thickness of the hot rolled strip, the scale or oxide layer is removed by pickling. In the cold rolling mill, the hot rolled strip is transformed into a finished product, cold rolled sheet, with or without coating. The mechanical properties of the steel strip are obtained by a heat treatment called annealing. The annealed and skinned cold rolled strip is now ready for final inspection and packaging. In most cases, additional corrosion protection is applied through passivization, protecting the surface from oxidizing or rusting. Metallic coating can be applied by electroplating. Electricity is used to deposit a metallic layer on top of the steel. Electroplated steel is used for packaging, such as cans and tins. Other coatings are obtained by passing the steel through a molten batch of liquid metal. These galvanized steel grades are widely used in various markets, such as construction and automotive. For pre-painted or organic coated steel, cylinders are used to apply a homogeneous layer of paint, giving the steel its final color and gloss. In order to make sure ArcelorMittal's steel stays at the cutting edge, research and development permeates all parts of the business, and innovative thinking is encouraged at all levels. We have a large research and development team with 1,300 full-time researchers in 11 research centres across the globe. Part of the R&D team's mission is to contribute to sustainable development by reducing the environmental impact of products and processes. This mission is rooted in ArcelorMittal's values: sustainability, quality, and leadership, and our philosophy of producing safe, sustainable steel. In the 1870s, the Scottish-American industrialist Andrew Carnegie called steelmaking the eighth wonder of the world, and we at ArcelorMittal agree. Look around you. Most of what you see would not be possible without steel, our steel. Since the beginning, steelmaking has not only helped create the world around us and millions of jobs, it has also been key to advancements in everything, from surgical equipment to the recent discovery of the Higgs boson subatomic particle. Steel really is the fabric of life.